Hey everybody, and welcome to your Lab 7 in Physics 1105 intro video. Okay, so this lab does require the lab kit. So what you're going to need is some string that hopefully you can find around the house, your mass hanger. You can see this, I hope, in front of my face. There we go. I took some of the masses off of it, but you can put some back on. This is 50 grams without any masses on it. You need this hard plastic tube, right, that you should have in your lab kit. And you need this rubber stopper, right? You also will need a paper clip and the string that I mentioned. Okay. All right. So let's take a look at the manual. All right. So let me go to the introduction to show you what we're going to be doing. So what you're going to be doing is you're going to tie a string to your stopper. This is an alligator clip, but a paper clip will do just fine. It's meant to just hold make it so the string doesn't come through the tube. This blue tube that you see there is this thing here. And then hanging from that is your mass hanger. Okay, with some weights on it if you like. And let's look at the theory that we're going to be dealing with. Okay, so there's quite a bit here. Our goal is to measure the period of the rotation. So what does that mean? So as you are swinging this tube around and around, your rubber stopper will be going around in a circle, right? And every time it goes from one part of the circle all the way back around to the same part, that time is called the period. Okay, so how can you measure the period? Well, you can count how many revolutions it goes. Say you count 10 revolutions. And if you time that, then you know that the period is just the time that you measured for those 10 revolutions divided by 10. Okay, but let's go through some of the math here. All right, so remember that when something is going in a circle, it has to have some acceleration towards the center, which is called the centripetal acceleration. And here you see that here, AC, which is v squared over r, and v is the tangential velocity. Now, you're not going to have to worry about that too much. Actually, this is actually the frequency squared, my bad. So sorry, this is new. It looks like a V on this font. So, and what we can see here is this quantity here, which is the same as this, is 2, and then pi, this looks like a P, but it stands for pi, over that period, which is T. Okay. So we can substitute this guy into this equation, and we get AC is 4 pi squared times r. Now, r is the radius. So if we go back to this introduction, you can see the radius is going to be from here to here, roughly, right? So we're straight across, all right? Which, yeah, as you're going to see, we're going to take a look at that. All right, so we'll look at the theory again. Okay, so now the centripetal acceleration is actually being given by a force, and that force is the mass hanger, right? The force, the weight of the mass hanger that is hanging down on your apparatus. Okay, so that is the source of the centripetal acceleration that's holding that stopper going in a circle. Think of it this way: if you all of a sudden took the mass hanger away and let the cord slip through the hole, the mass hanger would just go flying, right? It would go flying tangentially. So if it's going around like this, it would fly off. So it's the weight of the mass hanger that is keeping it going in a circle. So if we look, right, we can see that the force here is m stopper times its centripetal acceleration, right? And that force, that F hang here is the force from the hanger, is the mass of the hanger times G. In other words, the weight of the hanger. Okay, fine. So that means that I have an equation here that I can put over here, right? And I can solve for AC here. So I'm going to attempt to do this with my mouse. It's going to be a little funky because it's kind of hard to draw with your mouse. But if I look here, I can solve for AC. So I have AC, right? And that's going to be equal to F hang over M stopper. But F hang is just M of the right? M of the hanger, right? The mass hanger, times G. So I'm just going to put that in right away, right? So I'm going to put M and then hang. That's kind of hard because it's very small. Hang. Oh, this is hard to write. Hang. Okay. And then, right. And then it's G. So that's F hang, right? And then I'm dividing by M stopper to get this AC. So I'm just going to put this all over M, and I'm just going to use S for stopper, because if I try to write all that, it'll be crazy. All right, so MS. Now, if I go here, right, I can put that on this side of the equation. Well, I'll come back to that in a second. So first I'm going to erase this. So pause if you didn't get that. I'm going to erase this so I can go on to the next page. Kind of hard to erase. There we go. All right, let me go back here and let's go to the procedure. So here, right, you're going to set up the apparatus like we saw in the introduction. Here we're saying put about 200 grams on that mass hanger, which is more than just the hanger itself, right? And then you're going to rotate that, and then you're going to measure the rotation period. Okay, and you're going to measure the radius of that stopper going around. Now, it's not necessarily the length of the string because there's an angle. It's not easy to measure this. So we go back to our picture. Notice I said that let's see if I can annotate again. If we go back to here, the radius is really out here, right? There's an angle of radius, which is here. So it's very hard to measure this value here, but do your best. This is one of your sources of error, okay? So go ahead and figure that out and use the fact that it's very difficult to measure as one of your sources of error. Okay, let's go back to our procedure. Okay, so we're going to measure the radius. We're going to measure the period. And then you're going to do this again because you're going to change the radius by pulling the string right through the tube. Either way, make it longer, make it shorter, right? You're going to do this about 4 to 7 times, okay, for 5 different radii at least. Okay, now let's look at our analysis and we'll get back to the equations. So first, draw a free body diagram. That's what you should always do. Now you're going to plot t squared versus r. Okay, so remember t is the period. R is the radius. You're measuring both of these things every time you change the radius. Okay, so get your Excel out, put that in. And this should be linear. Let's go back to the theory. Okay, so we had, and now I've got to annotate it again because I erased it. We know what AC is, right? We solved for AC. We said the AC was equal to, and I'll just use MH for M hang, or M of the hanger, the weight hanger, whatever you put on that weight hanger, G, and then over the mass of the stopper itself. Now, how do you get the mass of the stopper? You do have a spring scale. You can weigh that stopper. Okay. All right. And it's the mass, not the weight, so be careful, right? Okay. So we have that. So let's put that into this equation here. So we're going to have AC. Actually, notice that right here is AC, which I have here. And so what I'm going to do is just put an equal sign here. And then I'm going to write 4 pi squared. I'm sorry, I do not have my tablet with me today. It is broken. Okay, R, and then over t squared. Now, remember, we need to plot t squared on the y-axis and r on the x-axis. So really what I should do is use this equation to solve for t squared so that I have t squared equals something times r, right? Okay, so how am I going to do that? Well, let's go up here and I'm going to pull this t squared up and multiply this here, right? So we're going to say t squared. Again, I apologize for the slowness. You can speed up the video if you'd like. T squared times M H G over MS. is equal to 4 pi squared r. All right, now here's the deal. You can, now I'm going to leave the rest to you, because what you can do is, of course, get all this over on the other side, right? And then whatever is in front of r is going to be the slope, right? Okay, so let's go back here to our analysis. Okay, and I better erase all that because it's going to interfere with you looking at this. Let's do that. Okay. All right. So, right? So t squared versus r, hopefully it'll look straight, right? And what is the slope? Well, it's that factor that you'll get when you do that, when you solve for t squared and have everything that's in front of the r will be the slope. So you can see, does it fit what you expect it to be? Okay. So that's your introduction. I hope that helps, and we'll be seeing you in the next introduction video for Lab 8. Good luck.